Okay, so today we're going to talk about sequences, but a special kind. So first of all, do you guys remember playing this game in like elementary school? Find the missing number? When school was fun? Okay, what's the missing number? First one. Anybody want to take a shot at it? It is 32. Genius. How did you know? How did you know it was 32? Always doubling. Okay, how about the next one? 13, how did you know?
Because it goes up by 3.
Each one goes up by 3. Okay, how about the next one? 127. Wow, that is phenomenal. How did you know that? Okay, and then 16. Wow, that's good. It's a power of 2 minus 1. So this is 4 minus 1. The next one is 8 minus 1, then 16 minus 1. Anyway, there's lots of ways to see these sequences, right? Luckily for you, we're going to talk about 2 kinds. Today we're talking about one called an arithmetic sequence. Actually, before we say that, let's try the trickier ones. Is that fair? Oh, it's 10:30. You guys are, I know teenagers are up by 10:30 for the most part, right? No? 1, 3, 6, 10, 15, 21, and? Sorry? 28, yeah. How did you know? Yeah. It's going up by 2, then 3, then 4, then 5, then 6. So the next one goes up by 7. Here's a very, very famous one. Anybody know what the next number is here? "21 is correct. Enlighten us. He told me. That is a good answer. So he told me. Can you tell us how you knew? Yeah, so you take the previous 2 numbers. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 gives you the last one, which is 21. Don't worry, we're not going that far into it. Does anybody know what this is called? I'll make you nerds yet. This is called the Fibonacci Sequence. This is, anybody see Da Vinci Code? Not a single person, one person? Okay, well anyways, there's a part, go see that movie. This is in that movie. It's famous. Everybody loves it, and you don't even know what it is. So there you go. Your homework is to watch the Da Vinci Code this weekend. Arithmetic sequence. That is a sequence where consecutive terms differ by a constant. Now, here's the hard part about defining stuff in math is usually the definition is really complicated, but the math itself is actually probably simple. So I'll tell you this here is an arithmetic sequence because every number differs by 3, 3, 3, 3. Okay? So no matter how far out you go, it always changes by 3. That's what makes it an arithmetic sequence. The other ones, something else is happening. Okay? So you can safely assume that it'll always be that same number. Oh, that should say Math 11. I apologize. To promote you guys here. There we go. So what we call that is the common difference, and that's the most important part of the sequence. So the common difference is the difference between any term and the previous. Did anybody print their notes? Okay. How you liking it? So you'll start selling more people on it, I guess, eh? Okay. So we want to work with these sequences, and I'm going to help you develop a formula for it, okay? So here's the first thing. I got a little table organized here. Hopefully you can follow my table. But here's the term number, and here's the term itself. So this is the actual sequence that you would look at. The sequence goes 2, 4, 6, 8. Who do we appreciate? Okay. It's always good to check if you're awake, that's all. So now I know I got, well, at least one person's awake here. What's the common difference, you think? 2 is the common difference. Each number changes by 2, okay? So I'm going to just collect this down so you can see how the pattern unfolds. Whoops, that should be a pen. There we go. So if I wanted to describe this, it's going to look a little funny to start, but instead of calling it 2, I could call it 2 plus nothing. Instead of calling it 4, I could call it 2 plus 2. Instead of calling it 6, I could say 2 plus 4. Instead of calling it 2, I could call it 2 plus 6. Why do you think I've chosen the number 2 in there? Where do you see the number 2? What's important about the number 2? It is a prime number, but I don't know that we'll need to use that in this sequence. Why do you think it's a little more, I don't want to say, it's never obvious, but it's a little simpler of an answer, I guess. Why do you think 2 is the important one that's there? Yeah. It's the first one. So 2 is our starting point. If we want to know how to get somewhere, it's like you're at 2, and how many common differences are we going to put on it? So if you're at 2, there are no common differences. You don't have to stop. You're already there. If you want to go to the next term, it's 2 plus 1 common difference. 4 is 2 differences. 6 is 3 of the differences, right? So that's how you move through the sequence. What would that look like then? Well, for example, if I wanted to know what's term, let's go up to term 20. Okay, what would term 20 be? How many common differences do you think I've got to add if I go all the way up to 20? Does anybody see it? Just give yourself a minute. I'll ask for an answer in a sec. Just look and see if you can figure it out. If I want to step from the first term to 20, how many common differences were there? At the very far back there. If you start from 2, there's 19 is correct. 19 common differences. Because you need to move 19 times to get from the first term to the 20th term, right? Okay, let's try it again. I'm going to fill the pattern in a little quicker for you this time. Here's the terms themselves. This is the sequence that we're actually trying to describe. And we'll try and come up with a pattern. So 7 is the first term, 7 plus 0. 7 plus, well, I have to take 3 away. I'd have to take 6 away. I'd have to take 9 away. I'd have to take 12 away. The common difference here is negative 3. That's why the numbers are negative this time, right? So now my pattern is no common differences, 1 common difference, 2 common difference, 3, 4. So it's nice because it's going to work whether they're positive or negative. Okay, let's see if you're getting the hang of it. If I go up to 25, how could I figure out how many common differences do I need to get there? 25th term will have 24 common differences. So it's going to be the first term, move 24 times the common difference. So for us, that's what the number is. So it's nice because I don't have to list all 25 terms. I can use the formula to get there, and it doesn't matter, right? I can skip over all the ones in the middle. So from those patterns, here's how we build up the formula. Term n is equal to the first term plus n minus 1 times the common difference. So I'm going to tell you what all those letters mean. This is the nth term. Like you'd write it like this, term 6. I'll tell you this all year, but I know for a fact that mathematicians are the laziest academics ever. I was one of them, and I can tell you I probably ended up there to start because I didn't like writing lots of stuff. And so that's what they do. Instead of writing out term 6, they just write T6. There's lots of abbreviations, and that's just one that you'll see in this unit, okay? So n is the term number you're looking for. A is the first term, and D is the common difference. Okay, so we'll practice. I know I just threw that at you, but we will practice using those terms. It kind of looks strange. There's 3 letters in your formula, but it's pretty easy to work with, I promise. So we want to try to shortcut all that long stuff we were doing before. And what I want to see is, if this is the sequence I give you, I want to know what's the general term. That's this right here. So can you find a formula? And once you find the formula, what's term 25 and what's term 50? Okay. So I'll do the first one with you, but I'd like you to try the second one on your own. Do people need a minute to catch up to me so that I know you can pay attention here? Is that any objections to me keep going? I'll pause. Okay, so there's all these pieces that I need. I need to find the first term, the common difference, and that's going to stay in here until I know what number term I'm looking for. So here's here's some free points. What's the first term in this sequence? Well, let me ask again. What's the first term in this sequence? 16? Are you sure? So 8 is the first term. Yeah? Okay, okay. Glad we can all agree on that. Okay, here's a 1 notch up in difficulty. What's the common difference? What do you think? Put it on your hand. Hold your hand up. What's the common difference? Okay. So I can now write the formula out. The first number is 8. And the common difference is 4. All right? So this is what your formula is going to look like. All that's left is for you to tell me what term number you want. In this case, 8 plus 25 is the term I'd like. And here, 8 plus 50 is the term I'd like. Okay, so can somebody, did anybody else get 104? Yeah, thank you. And then I'm going to assume I did this right. But I'm pretty bad at making careless mistakes because I'm a lazy mathematician. So like I'll be able to do all the complicated stuff for you, no problem. And then I feel so proud of myself, and all you guys are like, who cares, Mr. Joyce? But then it comes to the simple stuff like punching it in a calculator, and I always mess it up. So thank you for confirming that. Next one's your job. I'm only putting an answer up. I'm not walking through it. So your turn. Work with a partner. And I'll put up an answer for you to double check your work. Okay, so how'd we do? Thumbs up if you're on the right track. You got them all right. Thumbs like this if you're happy, maybe you got one of them or part of it. Let me see. Hold them up. Okay, so let's move on then. It looks like we can keep going. Okay. How about this? Uh-oh. Uh-oh. I'm gonna be perfectly honest with you up front. We're just gonna practice rearranging the formula now. That's all we can do. That's the only tool I've given you is a formula. All we can do is rearrange it. So let's think about the formula here. What can you figure out, looking at that sequence, what can you figure out from that formula? Like what can I actually say, oh, it's not an n, it's a... What do you think? What can I put in there? Sorry? I just said you couldn't hear. 70. You've already found the answer? Is that what you mean? 74. Where do I use 74? No? Okay. Sorry. What can you There's one thing you can go right. You should look at it right away and say, God, I can't believe you're even asking me, Mr. Joyce. This is the silliest thing to ask. There's one there that you should just be like, okay, what can you put in just looking at it? You don't even have to do math. The first number. We have the first number. It's right here. Yeah, no, I'm not asking you for an answer. That's crazy. I'm not just going to say, hey, what's the answer? I'm just saying we got to figure out how to rearrange this formula, so we need to know what we've got. What else can you calculate? I hear some people murmuring it. What do you, yeah, the common difference. Yeah, so right there, we can figure that out. How did I get from -3 to 2? What had to happen? +5, +5, on and on and on. So I've got those. What else do I have? I actually have the number. I don't know what term it is, but I have the number. So I know the answer, 152, is going to be -3 plus n minus 1 times 5. Okay, so again, all I've given you is a formula. All we can do is try to work with it. Let's rearrange this. 155 equals n minus 1 times 5. So what'll that be? 31 is n minus 1. So n is 32. It's not that exciting, but putting a happy face on it sometimes makes it better. Girls, you know what I'm talking about, right? Okay, try the next one. What term number is -65? Okay, so here is my solution for you. Again, all I have is that formula. I have to figure out what parts of the formula I can use. So same as the last one, I should end up with the 137th term. I hope. Can anybody confirm that to me, or did I make a mistake somewhere? Yeah. Oh, I did. Okay, good. No, that's good, because sometimes it helps to see that you're awake. I was just testing you. And that's 35th then. 35. Okay. That doesn't really look like a good 35. Let's try that again. 35. Good. Yeah, that's okay. Thank you. I like the perfection, I do. It's got to be perfect. Okay. Now this is like the game you played before, is find the missing number, except there's more than one missing number. Oh dear. How many steps is there to go from 22 to 74 in that diagram? You sure? I didn't say how many blanks are there. I said how many steps are there to go from 22 to 74. Yeah, this is what honestly, I still do this when I have to work these questions out. 4 steps, but we're not talking about steps. What do we call them? Each one of those steps is how big is it? What do we call it? Yeah, common difference, right? So I know I had to move by 4 common differences to get there. Okay. The problem is I don't know what that was. How far did I have to move to get from 22 to 74? How far is that? Yeah, 52. So if I got 52, that's how far I got to move, 52, and I give you 4 spaces to do it. How big is each space? 13, yeah. So now we can, this is a nice part about these sequences, we can double check it too. Let's see. If I add 13, I get to 35. If I add 13, I'm at 48. If I add 13, I'm at 61. And this is the moment we've all been waiting for. If I add 13, I get to 74. So it worked. Okay, fill in the blanks on the next sequence with your neighbor, and I'll come see how we're doing with it. All right, here's where we're going to start. How did I get from 19 to -13? How many steps did I take to get there? 4 steps, right? So 4 common differences. All right. How far is that 4D? From 19 to -13, what happened? Negative 32. So that means the common difference is equal to negative 8. Right? So now I can go 19. I'm kind of running out of space here, but this will be 11, 3, and negative 5, and yes, negative 13. But how do I go the other way? Oh yeah, so I'm just going to add it, right? Because I'm going backwards. So backwards is going to be positive 8, so it'll be 27. And the pattern will keep going. Okay? No, did I do that wrong? Did I do that right? Did I do that right? Wrong? No, that's right, isn't it? Okay. All right, so we have 2 more, and the only reason they're here is because everybody freaks out when they see letters. They're like, oh my God, this isn't math anymore. This is just like, this is Greek. I don't know what you're talking about. But it's the same thing we've just been discussing. If I wanted to find a general term and the first 3 terms, here's how it works. The first term is easy, it's a 4. How do I get to the next term in an arithmetic sequence? I'm not talking about this one. What do you do to get from the first term to the next term? What do we call that? You move by a common difference, which in this case is 2 plus 3x. So it's going to look funny. It's going to be 4 plus 2 plus 3x. So that's going to give me 6 plus 3x. Right? Okay, how do I get the next term? How do you get from the second term to the third term? What would you do? Yeah.
6 plus 3x plus 2 plus.
Yeah, you just add the common difference again. So I know it's scary because there's letters there, but all we do is we add a common difference to it. So it's going to be 6 plus 3x, that's the term before, and we're going to add the common difference. So altogether now I'll have 8 plus 6x. Okay. So those are the first 3 terms. 1, 2, 3. If I wanted to make up a formula for the general term, I know it's real scary because of all those letters, but it's actually easier than the ones we've already done, because this time all I have to do is put the values I have into the equation. Right? So you know, that's actually I guess it's a little harder because of the letters, but it's easier because it's already there. It's just anyway. That's what it'll look like. We could simplify that a little bit, but I'm not interested in seeing it simplified anymore. If those, let me see here. If those were 3 consecutive terms, how do you find their values? Let me see here. I'm just trying to think if we're going to run out of time to do this one. Yeah, you know what? I'm going to do this one with you guys. I don't want to take much more of your time. Our activities at the beginning of class went a little bit longer. So what I'm going to do is maybe the beginning of next class I'll start up there. Here's what I'd like you to do. Page 17, numbers 1 to 11 is where we're going to start today.